Hello, my name is Jonathan Fairley, and my instructor for Fundamentals of Physics is Corin Rombach. Today I will be discussing how game designers use physics to create gameplay mechanics and worlds for players that are believable and fun. Some of my favorite games involve physics as part of their rule set just as much as any other gameplay designs created by the game designer himself. Mario, for instance. Mario is as much about making those jumps and understanding how high you can jump compared to, what's going on around you as, shooting fireballs. While the topic of physics and game design is pretty expansive, today I'll be discussing the 3 laws presented by Isaac Newton and in 3 different demos I've created myself. So let's get started. As you can see here, we are now in Unity 3D, and Newton's first law states that every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. Here I've created an object, one with a much larger mass than the next, but I have also set the drag on the secondary, the smaller object, to be similar to as if the larger object, say a watermelon, was falling onto a steel ball. Now, through animation I could make the object shatter or what have you, but we'll just play this and see how this works out. Here we go. So as you can see, the ball falls, pushes against the other ball that was not in motion, causes it to be in motion, and then alters the path of the larger ball, aka the watermelon, demonstrating Newton's first law. Newton's second law states that the acceleration produced by a net force of an object is directly proportional to the net force, is in the same direction as the net force, and it is inversely proportional to the mass of the object. So, I'm going to demonstrate this in a program called GameMaker. GameMaker is not as in-depth as Unity 3D in its ability to edit the physics of a world. However, with predefined masses of objects, you can edit the gravity or the direction of speed after player input or on spawn. So here I'm going to open up my bomb object. Now with the bomb object open, you can see here that we can add events and then change the actions of the object based on whatever events we determine. Here I'm setting the gravity, and this is 0.05. The game actually moves really fast, so I'm setting it at a relatively low number. But this box here is important. With this box checked, each time the object spawns, the gravity becomes faster. Well, it becomes relative to the object speed as it was removed from the world before. So let's show this in motion. This was Newton's second law. I'm ready to save that. We'll play the executable here. And there's a small prototype I'm actually working on for my first game. Here we go. So the game begins. The bombs begin to fall very slowly. There's no actual force pushing down on them. It's actually just the Earth pulling on them and gravity itself, just like Newton's second law. As you can see now that the acceleration becomes faster over time, just like throwing a rock off a cliff and falling it, the set speed from gravity. Okay, and I'm about to lose, so let's go on to Newton's third law. Finally, Newton's third law states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. Here in Unity 3D again, I have built a wireframe sphere diagram of the Earth and the Moon. You can see that I've predetermined the mass here of the Earth, which in this case is not exact, and then also the mass of the Moon here. So when we hit play, you can see that the Moon rotates the Earth based on a determined velocity from the gravity of the Earth pulling on the Moon and the Moon pulling back on the Earth. It never comes all the way to the object, it just continues to rotate around. So, this is an example of Newton's third law. I hope you've enjoyed this brief overview of how game designers use physics to create gameplay and fun for their players. Again, my name is Jonathan Fairley. Thank you.